So we've talked about getting data in. We saw the workload unit implications around that. Um, and so as a way of looking at other metrics of concern, we want to now think about like getting the data out and delivering that to the client's device. So within there's workload unit savings and performance implications. So what I have done over the last like 15 minutes is I've ran some tests. I've had 2 different pages. I've ran these tests 3 times in a row for each one individually, spaced around 2 minutes apart. And I've been looking at the response and the timing. Those are my 2 main concerns. The response being the number of characters, and then the timing being the content to download. So for me, content to download is going to be like a performance indicator. The response, the character count, and the number of responses will be a workload unit indicator, but we'll also look at the workload unit metrics themselves and be able to see exactly what it is that Bubble's charging for these different things. And also just to be able to kind of demonstrate it live as well. So one thing that was kind of strange to me, content download. I saw wildly different numbers throughout on both approaches. And so within content, I've got some snapshots of that. So for fairness of it all, I'm going to demonstrate these live as well. And so this is the legacy. And so I'm just going to go ahead and refresh this. Just as a sort of FYI, I have this repeating group that is set to show the 100 items that's within the database to show all items immediately. So that way we are getting a true sense of what does it cost to download and display the 100 units or the 100 things. Okay, so where we want to look at is our M aggregate. We can see here timing. Timing went down on the content download. It's 2.56 here. This is basically like the 4th load of this page in a row with this tab open. So like the way bubble caching is supposed to work, like you would expect the content download to kind of like go down further. Now, with that being said, like I do have a feature that I'll be releasing soon. It's already built. It's just not in the Data Jedi plugin, which is for doing your local storage. So like for certain types of data, like you can even make it so that there's nothing to even download from the server at all. But in this, we're looking at it from a perspective of how can we kind of anticipate like 100 objects, and maybe we can expound that out and see how we perform with like 1,000 objects. So here with 100 objects, your legacy data approach, 2.56, and then our response here, we're seeing, oh, am I in the wrong way? Search, yeah, response right here. This is where we want, oh, and this is why I should look at timing here, 6.34, okay, so 6.34, it went down from the 8. All right, so here our response, we want to see how many characters in total. So it's pretty simple. We just highlight everything and we can see how many characters are getting returned with this. And so as we go down, it's been consistently 87,858 characters. Now you can see there are some extra things that are being returned to you by Bubble. You can see the total number of objects that got returned, right? Remember, workload units, you get charged for how many objects are being returned as well as total character count. So you got 100 objects getting returned. And then character count. Well, we've got here extra characters that are not within your data type, but are being returned within this response off of every single one of the objects, so 100 times over, okay? And so what you've got is the ID and the type. And when we take a look at this, we can see here, we've got ID already up here. And we have the type already up here. So what Bubble's doing there is they are doubling up the type and the unique ID 100 times over. So the type is also one of these fields that are being returned to you with character count, obviously going into the workload unit costs. that are like nowhere for you really. It's just your data type signifier. It's an ID. And so with this, like you can see how there are some more characters being returned just based off of some of these extra types of values. Now, the other thing too, you notice like every single one of them has a created by, has a modified date, has the created date. We also got a version here. So those things, they all add up, right? Like that's how you can get to 87,858 characters on your 100 items. That really only has a first name, last name, an email, a phone number, and a gender that you are interested in. And so, like, we want to basically reduce our workload units and improve our performance, especially with searches being returned, right? So within that, we can now turn to the Data Jedi approach. And so here, let me just clear this for the ease of it. If I go ahead and refresh this, which again, this is on the 4th refresh, same tab open, again, repeating group set to show all items immediately. So I've got the mget here, and the m, which is nothing, APM is nothing. We got mget. We're not doing a m search. We're not aggregating. So you also don't have to deal with the m aggregates cost and such. So or the bulk watch going on. Which, bulk watch, okay, maybe that's going to remove some kind of functionality that you might be interested in, like real-time updates, but at the same time, that's not an issue with Data Jedi because all your processing client side would be happening, by them in real time. Now, of course, that's not going to incorporate other people on other, accounts or on other, browsing sessions, but like at the same rate, it's a use case type of situation, so, and you play off benefits from different approaches. So here, with our mget, our timing is 0.53 milliseconds, which as that compared to this last search here of 6.34. So that's a pretty significant difference there. I'm not going to say that is the par for par type of difference. It's not, because as I mentioned earlier, like I've seen wildly different numbers across both of these. Like my first refresh of the Data Jedi approach here was like 30 something milliseconds, and then the second one dropped down to like 2. So it is what it is. It demonstrates overall that consistently Data Jedi is faster, but again, like it doesn't really register for me off top of mind as to exactly why you could see such wildly different numbers from refresh to refresh for the same approach. To be able to try to isolate exactly what's a real value that we can kind of compare the two different approaches against. I suppose multiple tests and just look at averages and then extrapolate out. So that would probably be sufficient. So in this, we get our response where we can definitely have consistency, and that consistency is such that it returns only 37,268 characters. And so that's a pretty good difference. I actually asked ChatGPT to do some math for me beforehand off of some of my first things, so like the count here. So basically, the legacy approach is around 139% more characters than the Data Jedi, or in other words, Data Jedi is around 58.2% less characters comparative to the legacy approach. The other thing, if you haven't noticed, if you're not that familiar with the network console and these searches, this is a search. This returned 100 items. This is an mget. This returned 1 item. And so, what do we get as a comparison? Well, 100%, right? Like it's that much better. So we can now take a look at like inside the logs. Let's look at the workload units. I'm just going to go to the latest hour. So I did at 620, 622, and 624 the legacy 3 times in a row. And then at 626, 628, and 630, I did the Data Jedi 3 times in a row. Just at first glance, you can see this nice little difference there, right? Pretty dramatic. So we'll take a look here. This is overall what? They've got it listed as a 2. So we got fetching of data 2.16. 3 searches went on. Page load is page load, right? Like you're not going to get away from that. Fetching of data 2.174 searches. So where were we? This was 3 searches, okay. And then this one, okay, so pretty similar. So you've got your search, which was 1.95 workload units, your aggregate, which was another 0.2, and your real time of 0.01. I bet you across the board is pretty much what you're going to expect when you're looking at fetching data in your kind of legacy approach. So you got the search, the aggregate search, the individual data requests, no idea why that snuck itself in there. Real-time search is right there. Fetching data, the search, aggregate, real time. Okay, so pretty consistently across the board, these numbers look like they are pretty accurate in reflection of just fetching those 100 items from your legacy approach, which is a 2.16 workload unit to fetch out 100 items. So we'll take a look at the Data Jedi. So Data Jedi page load, you can't get away from it. Fetching data, one search, 0.011. It's a individual data request. It's a Jedi approach, right? We got a 0.11 across the board consistently, every single time, okay? With no other things kind of sneaking themselves in there. As you saw when we take a look here, you've got 3 things. Here, you've got the 3 things, right? And then here, you've got a nice little, hey, there's another welcome 4. Like, yeah, I'm going to sneak right into that party. All right, so not only do we have the cheaper workload units, but maybe even like a little bit more consistency within the charges that are getting applied to them. But I don't know, perhaps, I don't know, maybe I did something. Maybe that individual data request is not just a surprise and I somehow forgot I did something during the time. I don't believe so. All right, so we can mark these down as pretty much spot on accurate for what's the difference in workload unit cost to return these 100 items. It is a difference of 2.16 workload units from the legacy approach to 0.11 for Data Jedi. Okay, so we can just go in and just for the fun of it, have ChatGPT give us another kind of comparison. All right, so please compare legacy of cost 2.16 and Data Jedi cost of 0.11. Okay, so this is pretty in line with what my previous tests have shown. All right, so in 2 different ways of speaking, we can say that the legacy approach costs 1,863.6% more than the Data Jedi approach, whereas we could also say the Data Jedi approach is 94.9% cheaper than the legacy approach. For me, pretty convincing numbers there. So sounds like a win, right? Like cheaper workload units by significant factors to get the data in, cheaper workload units by significant factors to get the data out, cheaper, or rather improved performance in terms of speed to get it in, and also improved performance of fetching it. So yeah, plus add in that modularity that you can get from it, and man, incredible power that the Data Jedi plugin can put into the hands of a developer.